You are hearing me, right? You understand what I'm saying. Primary auditory cortex is damaged. What if secondary auditory cortex is damaged? You came to the right place. This is MBS here. Welcome to my YouTube channel. Let's kickstart the video.
എന്താണ് പേര്?
மலர்.
மலர்.
என் பேரு சொன்ன. உங்க பேரு?
உங்க பேரு?
Now you are seeing the scene, right? Okay. Now let's see some basic arrangement. Afterward, we see the medicine behind the scene. Here, this is the subject we are going to deal with. This is the subject, and now we are going to magnify the internal ear, the internal ear structure of this lady, and this is going to be like this, right? This is your tympanic membrane, and this is your middle ear cavity, and this is your inner ear cavity. In the inner ear, these are the three semicircular canals, and this is the vestibular apparatus, which is nothing but the utricle and saccule, and this is the cochlea. Okay, we are going to much concern with the cochlea because this is concerned with the auditory mechanism. Just consider a cone in front of you. Okay, this is the cone. This is the cone in front of you. Okay, if we rotate this cone in an upside down pattern like this, just consider this is the cone. We are going to rotate like this. Okay, and it will be look like this, right? And it will be look like this. Okay, now what we are going to do is we are just wrap this cone. We are going to wrap this cone with some paper. This, so here it will be look like this. Okay, just consider a cone in front of you. We are going to wrap this cone with some kind of some paper. Now let's see the structure. See, as I mentioned before, this is the cone. Okay, this is the cone as I mentioned before, and this part is the wrap. This part is the paper that we are actually wrapped around the cone. Here, see, this is the cone. This is the cone part, and this is nothing but the paper that we are actually wrapped around the cone. And this cone part is actually called as the modulus. And this wrapped, right? The paper that we wrapped around the cone, right? And this is called the cochlea. Now we are going to focus on the apex part of the cone. Okay, apex part of the cone, and it has the paper around it. Okay, and it will be look like this, right? Okay, let's see. At this point, we are going to have a cut section at this level. Let's see. This line is going to be this line, and this line is going to be this line, and there is a meeting point, right? They are actually continued with each other, right, at this apex point. So this is going to be like this. Since we are reading about the cochlea has 3 tubes, so we are going to add an additional tube inside this. So this is going to be our scala vestibuli, this is going to be our scala tympani, this is going to be our scala media, and this continuous, the 2 tubes, the scala vestibuli and scala tympani are continuing with each other at a point, and that point is called as the helicotremma. Okay, let's see the real picture. Now we will got some orientation about that. Okay, see, as I mentioned before, the cone is actually like this, but we are going to view in this position. Okay, right, in this position. So this is our wrap, nothing but the cochlea, and this is our cone, which is nothing but the modulus, and at the apex of the cochlea they actually continue with each other, right? And this is called the helicotremma, and this is the apex. Okay, this is the apex, and this picture is depicted at here. See, this is nothing but the scala vestibuli, and this is the scala tympani, this is the scala media, and the scala vestibuli and scala tympani are continuing with each other, and this is called a helicotremma, this part. Okay, now we got the better orientation about the cochlea and the arrangement, right? Now at this point we are going to take another cut section. Okay, let's take here. Okay, and this is gonna be like this one. Okay, now this typical, let's see this picture. This is our scala vestibuli. This is our scala vestibuli. This whole part is called the scala vestibuli, and this part is called scala media, and this part is called the scala tympani. Okay, resinous membrane. With the help of resinous membrane, they are actually separated from each other with the help of basilar membrane, which means the scala media and the scala tympani are separated by basilar membrane, where the organ of Corti is actually lodged. The organ of Corti is actually lodged. Okay, what is cochlea actually? The cochlea has 3 tubes. Fluid which are present inside these tubes are perilymph and endolymph. The perilymph is actually rich in sodium, where the endolymph is rich in potassium. Okay, the endolymph is present only in the scala media, whereas the perilymph is present in both tubes, which is the scala tympani and the scala vestibuli. Scala tympani and the scala vestibuli. Let us take a look at basilar membrane, which is nothing but this part. Okay, now just I'm going to play an animation video so that we can get a better orientation about that. Okay, let us take a scene of a swimming pool scene. Okay, here's the swimming pool, and the green one is actually grass. Okay, let us take a man standing on the diving board. He is actually trying to jump, but the board is not moved so well, right? It's because it's actually fixed to the base. It's near to the base. Now take another example. He is actually doing the same thing, but now the board is moved quite so well. It's because it's actually away from the base. You saw that animated video, right? Now let's correlate with the basilar membrane. See, the basilar membrane also has exactly the same arrangement. If a high frequency sound is entered into the cochlea, means the base is going to vibrate. If a low frequency sound is entered into the cochlea, means the apex is going to vibrate. Okay, and this principle is called place principle. Okay, with the help of this place principle, the primary auditory cortex can know whether it was a loud sound or it was a whisper sound. All right, this is about basilar membrane. And on the basilar membrane, where the organ of Corti actually lies. Speaking of organ of Corti, this is the arrangement of organ of Corti. This is the basilar membrane. Okay, where the organ of Corti is actually rested on, and the organ of Corti consists of 2 hair cells, the inner hair cell and a outer hair cell. Okay, 2 hair cells, inner hair cells and outer hair cells. The inner hair cells are actually arranged in a single row, and outer hair cells are arranged in 2 or 3 rows. Most of the impulses, the 95% of impulses are just arrive from the inner hair cells to the peripheral process of the spiral ganglion. And the role of outer hair cells are, let's see the role of outer hair cells. Membrane called the tectorial membrane. Okay, now these are the outer hair cells, right? These are the outer hair cells. The outer hair cells, when they get stimulated, they become shortened, which means from this side they are going to be like this. So what they do means they actually establish a very close contact between the inner hair cells and the tectorial membrane. This in turn causes a release of more number of impulses to the peripheral process of the spiral ganglia. Okay, so if the outer hair cells get stimulated, they become shortened and they establish a more close contact between the inner hair cells and inner hair cells and the tectorial membrane. If they get hyperpolarized, which is nothing but if they get inhibited, means they become lengthened and the contact between the tectorial membrane and the inner hair cells is actually decreased. Okay, this is the role of outer hair cells. This is the main role of outer hair cells, and they get repolarized. They get hyperpolarized or they get inhibited by olivocochlear bundle. We will see that in our following slides. Okay, now let us see the magnified view. See, this is one hair cell. Okay, this is our inner hair cell. We are going to magnify this. This is the one hair cell. And it consists of numerous numbers of cilia. Look at here. This is one hair cell. It consists of numerous numbers of cilia. Okay, numerous numbers of cilia, and these are called as the stereocilia. One cilia which is higher than the rest of the cilia, and this cilia is actually facing away from the modulus. It's actually away from the modulus, and the shorter cilia are actually towards the modulus. The modulus is nothing but, as I mentioned before, a cone structure, right? And this is called modulus. The stereocilia which are towards the modulus are shortened one, and the largest cilia is actually away from the modulus. Okay, and in between them, these stereocilia are connected by tip links. They are actually connected by tip links. At this junction, the mechanically sensitive cationic channels are present. Okay, the mechanically sensitive cationic channels are present. We will see that role in our following slides. Okay, these are the